Hi, my name is Raju and I am an expert in post-silicon validation and VLSI with almost 10 years in engineering. In semiconductors and VLSI, there are so many different career paths for freshers and college students. One might ask, should I pursue design only? What about digital design versus analog design? Is verification the better career choice or validation? Well, today I will go over the post-silicon validation career path in VLSI and semiconductors and how to start in it as a career. Put simply, there are four key functions of post-silicon validation. Number one, happens after the silicon chip is manufactured but before mass production or say. Number two, focuses on real-world testing beyond what pre-silicon simulation is capable of. Number three, validates performance, functionality and reliability of a semiconductor chip before it reaches the customer. Number four, and perhaps most critical, detects bugs not caught in pre-silicon. So let us try to understand. Basically, as an engineer in post-silicon validation in VLSI, we will be dealing a lot with the final manufactured silicon. So that means a lot of lab work, powering up chip, automating temperature ramp of the chip, writing scripts to read and write to chip registers, and automating instruments to take measurements while chip is running. Hope I am not confusing you. Anyway, we will take a deeper look at these tasks now. So before we get into details of post-silicon validation day-to-day tasks and work environment, let us try to understand how does post-silicon validation fit into the bigger picture of quality assurance in VLSI and semiconductors. There are three main phases of quality assurance in VLSI as you can see in this flow diagram. First is pre-silicon phase known as verification. Second and third phase are known as silicon bring-up phase and post-silicon phase, respectively. As a validation engineer, you would be involved in both of these phases. Silicon bring-up phase is the first phase after receiving the chip from manufacturing. Typically, this chip could be referred to as a sample. Validation team would work to bring up the chip in lab. So testing basic functions and making sure there are no major or catastrophic issues with chip. In post-silicon phase, additional thorough testing and analysis for customer would be done. So testing all different process corners and voltage extremes, working with product engineering for statistical analysis, and helping test team start mass testing of chip. As you can tell, validation engineer is involved in many different aspects of post-silicon activities. So let us try to understand basic work environment and setup of validation engineer. This picture shows a validation setup from Intel. You can tell it is very complicated, but there are main components common to all post-silicon validation setups. First component would be the validation board which holds the chip. Second component would be all the peripheral boards and chips needed to use the chip similar to what customer would do. So for example, perhaps crystal oscillator is needed to provide precise clock to the chip. All such components would be laid out onto the validation board or peripheral boards. Third component is wiring to connect validation computer to the chip and enable communication. Fourth component is oven for temperature ramp. Why we need oven? Well, to generate datasheet for the chip, generally customer wants assurance that it can operate over all temperature, such as -40 Celsius to plus or 50 Celsius, as an example. So validation engineer must characterize the chip over temperature before release to market. So here is another way to think of validation setup. Let us try to understand. Here we have a computer and validation platform. Computer is controlling stimulus to chip and adjusting parameters like voltage and temperature. Simultaneously, it is also taking measurements and recording data. This data is then analyzed by validation engineer to make sure it is within the spec. If something happened and data is not in spec, then validation engineer needs to debug. Is it setup issue or it could be design issue? In this case, validation engineer and design engineer do a collaboration to debug the issue. As you can see, validation engineer is a very collaborative job. So now I have given you overview of a typical validation setup and different components. You have seen what the goal of validation engineer is. Now, let's talk about the skills a validation engineer needs to succeed. Number one, Python scripting to automate equipment and take measurements. Even data analysis skills in Python and Microsoft Excel would be great. I would personally say learn pandas and NumPy too. Number two, collaboration and people skills. Be a good team player. Number three, good understand of customer goals and requirements of chip. So if you are in university or college now, I suggest to do a project to test a chip and make sure it lies within customer specification. Number four, broad understanding of VLSI concepts. Try to cover as much ground as possible. Concepts like metastability, clock domain crossing, synthesis, timing, and basic analog and digital components are great to know.